Good morning, ladies and gentlemen. My name is Putra Satilaksono, and this is my partner, Gita Diraskarahini, and our research title is Automatic Identification of Natural Pigment by using Arduino Uno Microcontroller.
What is pigment? Pigment is a very small particle of colored material that is mixed with a binding medium. The pigment gives paint its color. And what is the use of pigment? Pigment is used in primary needs such as food, clothing, and housing, and also in secondary needs such as transportation, industry, even in art. How about the use of pigment for Indonesian batik? Indonesian batik is a masterpiece declared by UNESCO in October 2009. Batik using natural pigment has a higher aesthetic value for health and environmental friendly. Indonesia is a rich country of natural pigment. It is a potential of high value commodity as the main component of batik production. This is the research of background. There is two kinds of pigment. The first one is synthetic pigment, that is large-scale production, consistent color, but it is environmentally unfriendly. For the natural pigment, it is environmentally friendly, but it is inconsistent color and small-scale production. Based on our research background, this is the objective: automatic identification of natural pigment by using microcontroller Arduino Uno, that we want to make a pigment that is environmental friendly, large-scale production, and consistent color. Methods and hypotheses. The stages are literature review, system design, system developing and testing, data gathering and analysis, report and conclusion. For the hypothesis, automatic identification of natural pigment can be developed using TCS 3200, salinity sensor, and Arduino Uno Microcontroller. Literature review. From the textile dyeing, the first step is natural fabric preparation. Second step is natural pigment extraction, and then fabric dyeing. And the next is color fixation using natural color. For the color theory, we use RGB and CMI color digital model. And for the digital identification, we use salinity sensor, TCS 3200 color sensor, Arduino Uno Microcontroller, and Arduino Uno Microcontroller. There is a lot of natural pigment can be found in nature. We can see in this picture there is a picture of parcel and mangosteen, and then the chemical compound. And then this is also the picture of curcuma and the chemical compound.
So this is the automatic identification system. So this is a system circuit of automatic identification of natural pigment using the salinity sensor, TCS 3200, and Arduino Uno. This is the workflow diagram, and TCS 3200 for automatic identification of pigment solution and fabric color, salinity sensor for identification of salt concentration of the depreciation process. This is our experiment. We do two kinds of experiment. First one is for salah telang and mangosteen pigment experiment. We use 1 to 3 and 4 grams of salt. And the second experiment is salt fixation in 1 to 3 and 4 grams of salt using curcuma pigment. So this is our result on telang mangosteen aerosola experiment. And we could see in the table that the higher the salt concentration, the darker the color result will be. So this is the salt concentration experiment. This is the red component, green component, and blue component. In the red component, we could see there's also, the blue line is 1 gram, the orange line is 2 gram, and the gray line is 3 gram, and the yellow line is 4 gram of salt. We could see in the graph that Rosella numbers of RGB has high in red, green, and blue component. And for the tulang flour, you can see that the red component is low, the green component is in the middle, and the blue component is high. And for the mangosteen, the red component is in the middle, the green component is low, and the blue component is more lower. And we could also see in the circle, there is the experiment of salt concentration using curcuma. You could see there is a consistency between curcuma 1, curcuma 2, curcuma 3, and curcuma 4 in 1 gram of salt. And also in 2 gram of salt and 3 gram of salt and 4 gram of salt. You can see that in the red component in 2 gram of salt, the number is 170, and it's consistent between the curcuma 1, curcuma 2, curcuma 3, and curcuma 4. And also in the green component and blue component. So this is the salt concentration experiment. We can also conclude that in the line profile and the that 1 gram of salt has more fluctuation, 2 gram of salt decrease the fluctuation, the 3 gram of salt also decreasing, and the 4 gram of salt is more even. So we can conclude that the more gram of salt is added, the more even the color will be. So our conclusion is 3. The first one is based on Versala, Magenta, Mangosteen Yellow, and Telang Cyan experiment. The digital system can identify accurately and precisely the color characteristic of natural pigment. Second, based on the salt concentration experiment, the digital system can identify accurately the difference of color result in different salt concentration for precision that cannot be identified by human eye. The digital system can identify that the higher the salt concentration, the more even the color would be. The automatic identification system by using Arduino Uno Microcontroller can be used to automate the textile dyeing process using natural pigments more practically and accurately. So our future work is more sample of natural pigment from Indonesian biodiversity is needed to enhance the performance of the system. Digital database research and development for natural pigment data collection is very important for the future work. This is our reference. Thank you for watching. Hello guys, now I'm going to present the color sensor. This is the bundle of 4 grams of salt in the curcuma. So this is curcuma 1, curcuma 2, and curcuma 3, and curcuma 4. This is the sensor, TCS3200 and Arduino Uno. This is the coding. You can see this is the coding. Okay, so now we're gonna sensor the color using the color sensor. So this is the coding. So we open the serial monitor. So this is the color for the curcuma number 1, number 2, and so on. And we try to the curcuma number 2. It's like this. The number, the red is the same number actually. And we tried in the curcuma number 3. Okay, it's also the same number, 126. And we try again. And okay, for the fourth curcuma is 72. So from this experiment, we can conclude that there's a consistency between the grams. So if you put 4 grams of salt between experiment 1 to 4, it will have the same amount of color. That's all. Thank you.
I'm gonna demonstrate the salinity sensor. This is the 1 gram, 2 gram, 3 gram, 4 gram, and this is the salinity sensor. This is the Arduino, and then this is the code. So we want to dip the sensor to the 1 gram, and we open the serial monitor. You can see right here it's increasing the number.
Yeah.
The 2 gram. In the 2 gram, it's even increasing, and this is the 3 gram. You can see in the monitor. This is the 4 grams. Like here, you can see it's moving. So that is the experiment. This is the salt in a 25 milliliter of water.
Thank you for watching.